Welcome back to another Explainer. So today, we're unpacking a really fascinating paper that dropped in June 2026 by researcher Hao-Tao Shi. It's called System Report for CCL25-Eval Task 5, New Dataset and LoRa Fine-Tuned Qwen2.5. Okay, I know, that sounds like a massive mouthful of dry technical jargon, probably the least poetic title you could think of, right? But the core of this research is actually incredibly poetic. Literally. We're going to explore how researchers are teaching artificial intelligence to grasp the deep emotional nuance of classical Chinese poetry. It's this wild journey that bridges the gap between cold, hard code and the delicate artistry of ancient verses.
And this whole thing kicks off with a really fundamental question, one that gets right to the heart of what artificial intelligence is currently even capable of. Like, can a machine truly understand the emotion of ancient poetry? We already know AI is brilliant at processing massive amounts of data, crunching numbers and, spitting out standard text. But classical poetry? That requires something inherently human. It demands an appreciation for subtle metaphors, rich historical context, and deep emotional resonance. This massive contrast between the cold, calculating nature of algorithms and the soulful expression of human emotion is exactly what makes this research so compelling.
All right, Section 1. AI meets ancient poetry. We're taking a look at the limits of current large language models.
Okay, let's dive into this. Think about your everyday, general domain AI models, the ones we all use constantly. When you feed them a poem, they basically just treat it like standard text. They process the literal words, but they completely miss the deep context. They're essentially treating a heartbreaking 1,000-year-old verse the exact same way they treat a boring email draft about a Monday morning meeting. But true domain-specific poetic appreciation, that requires so much more. It's not just swapping words from one language to another. It requires precise translation paired with real emotional insight. Trying to treat poetry as a general domain problem is exactly why our current AI models just completely stumble when they face it.
So the researchers pinpointed exactly what the AI was missing, and they call it effective semantic understanding. This is absolutely crucial. Basically, it's the ability to simultaneously understand both the literal semantic meaning of a text, so what the words are actually saying, and its underlying emotional or affective resonance, which is how the words are supposed to make you feel. Imagine you're reading a poem about a falling autumn leaf. Semantically, sure, it's just a leaf dropping from a tree, but effectively, it might represent the fleeting nature of life or a deep sense of longing. General AI gets the leaf, but it completely misses the longing. This dual understanding is the ultimate missing link.
Moving on to Section 2, building a specialized dataset. This is how the researchers broke down the poetry problem. Since you can't exactly just find a high-quality, perfectly structured dataset for ancient poetry lying around on the internet, the researchers had to become specialized tutors. They couldn't just throw raw data at the AI. Instead, they broke the overwhelming, abstract task of poetry appreciation into 3 distinct, highly teachable subtasks. Step 1 is term interpretation, teaching the AI the specific definitions of ancient vocabulary. Step 2 is semantic interpretation, helping the AI grasp the literal meaning of the whole sentence in context. And finally, Step 3 is emotional inference, actually training the AI to deduce the underlying feeling of the verse. By breaking it down like this, they made the impossible teachable.
But to actually teach an AI, you need examples. A lot of them. Which brings us to this massive number, 49,404. Now, this isn't just a random statistic. This represents the exact quantity of high-quality instruction-response pairs the researchers painstakingly compiled. They didn't just casually scrape the internet. They meticulously built a custom, ground-up library to train their model.
They named this monumental achievement the CC Poetry 49K dataset. And to create it, they couldn't just use messy, everyday text. They had to perform rigorous data cleansing and alignment on multiple open-source datasets. They filtered out all the noise, structured the data according to those 3 specific steps we just talked about, and explicitly optimized every single entry for classical poetry. The end result is this pristine, highly specialized training ground. It's exactly the kind of focused curriculum an AI desperately needs to evolve from a generalist into a true master of poetry.
All right, Section 3, Training the Poetry Qwen model. Time to upgrade our AI hero.
Now, if you have a massive AI model like Qwen2.5 14B, retraining its entire brain from scratch just to learn poetry would take an absurd amount of time and computing power. It's just not practical. So the researchers used a super clever technique called LoRa, which stands for low-rank adaptation. Think of LoRa as a highly efficient, specialized tutor.
Instead of sending the AI all the way back to kindergarten to relearn everything, LoRa simply plugs a new, highly specialized module directly into the existing model. It fine-tunes the system for specific tasks using the new CC25-Eval dataset, completely sidestepping the need to retrain a multi-billion parameter system.
And what happens when you combine that pristine dataset with the super-efficient LoRa training? Enter Poetry Qwen. This is not your standard run-of-the-mill chatbot anymore. Poetry Qwen is a domain-specialized large language model explicitly designed for the precise translation and emotional understanding of classical poetry. It has been rigorously, meticulously trained to master those ancient terms, the complex semantics, and, most importantly, the subtle emotional inferences that completely stump general AI models. The hero is officially upgraded.
Section 4. The results are in. Let's see how Poetry Qwen actually performed on the CCL25-Eval Task 5 benchmark.
Now, what's really interesting here is the definitive proof of all of this hard work. The researchers put Poetry Qwen to the test against the standard, highly capable Qwen2.5-14b Instruct baseline model. And the baseline scored a very respectable 0.690. Not bad at all. But Poetry Qwen, thanks to its specialized training and that custom data set, it surged way ahead to achieve a score of 0.757 on the rigorous CCL25-Eval Task 5 benchmark. The numbers really speak for themselves here, showing the massive difference between a generalist AI and a true trained domain expert.
To put that into perspective, that jump in the score represents a 9.7% improvement over the baseline model. And in the world of empirical AI testing, especially for a task as subjective, deeply nuanced, and notoriously difficult as the emotional understanding of classical poetry, a nearly 10% leap is absolutely massive. It proves without a doubt that breaking down the task and providing highly domain-specific training actually works.
The author, Hao-Tao Shi, really hits the nail on the head in the paper. He states, "These findings clearly indicate that Poetry Qwen significantly enhances performance intended to support the domain-specific optimization of LLMs." And that right there is the absolute core takeaway of this whole explainer. General AI is incredible, sure, but if we want machines to actually master highly specific, culturally rich, and emotionally nuanced domains, we simply cannot treat them like general problems. We need specialized datasets like CC49K, and we need targeted fine-tuning techniques like LoRa to get there.
Which leaves us with a really thrilling thought to wrap things up today. These researchers successfully taught a machine to bridge the gap between literal text and underlying emotion in one of the most complex literary forms in human history. So if AI can actually be trained to untangle the profound emotion of ancient poetry, what other deeply human, highly specialized domains will it learn to master next? The possibilities are literally endless. Thanks so much for joining me for this explainer, and keep questioning the future.